In this question, we're given the complex number z with mod z defined as being equal to 1, and we want to find the minimum value of this expression, and then we want to find what is the value of z for which this minimum value exists. So we're going to begin with this expression here. So we've got mod z divided by 1 minus z all squared plus mod z divided by 1 plus z all squared. We use the identity that mod z1 divided by z2 can be split up into mod z1 divided by mod z2. So we can split up these two terms to get mod z squared divided by mod 1 minus z squared plus mod z squared divided by mod 1 plus z squared. Then we use the fact that mod z is equal to 1, and we're going to replace both of these numerators with just 1. So we have 1 divided by mod 1 minus z squared plus 1 divided by mod 1 plus z squared. Then to simplify this expression, we're going to express z using the polar form, which is z is equal to cos theta plus I sine theta. So we're going to replace both of these z's with this expression here. So our expression becomes 1 divided by mod 1 minus cos theta minus I sine theta all squared plus 1 divided by mod 1 plus cos theta plus I sine theta all squared. To simplify this further, we use the identity that mod z squared is equal to the square of the real part plus the square of the imaginary part, or x squared plus y squared. For our first fraction, the real part is 1 minus cos theta and the imaginary part is negative sine theta. So when we simplify this, we'll get 1 divided by 1 minus cos theta all squared plus sine squared theta. For the second fraction, the real part is 1 plus cos theta and the imaginary part is sine theta. So when we simplify this, this becomes 1 divided by 1 plus cos theta all squared plus sine squared theta. We're then going to expand both of these brackets. We've got 1 minus cos theta all squared. That expands to 1 minus 2 cos theta plus cos squared theta. And 1 plus cos theta squared expands to 1 plus 2 cos theta plus cos squared theta. Then using the trig identity that says that cos squared theta plus sine squared theta is equal to 1, we can reduce both of that to 1, and then we can collect the like terms. 1 plus 1 is 2. Again here, 1 plus 1 is 2. So our original expression can be reduced to 1 divided by 2 minus 2 cos theta plus 1 divided by 2 plus 2 cos theta. We then factorize out the half on both of these fractions, and the simplified expression is a half multiplies to 1 divided by 1 minus cos theta plus 1 divided by 1 plus cos theta. So now that we've established that our original expression in terms of z can be expressed as its equivalent in terms of theta, the minimum value of this expression would be the same as the minimum value of this expression. So we're going to begin by considering this expression inside the bracket. We're going to convert both of these fractions into a common denominator. So we're going to multiply the first fraction top and bottom by 1 plus cos theta, and the second fraction we're going to multiply by 1 minus cos theta to top and bottom. Our first fraction will reduce to 1 plus cos theta divided by 1 minus cos squared theta, and this second fraction will reduce to 1 minus cos theta divided by 1 minus cos squared theta. Now that we've got the same denominators, all we need to do is just add the numerators together. The 1 and the 1 will add together to give 2, whilst the plus cos theta and the minus cos theta will add and will cancel each other out. So this expression will reduce to 2 divided by 1 minus cos squared theta. We can further simplify this using the trig identity that sine squared theta is equal to 1 minus cos squared theta. So we have got this expression being equal to 2 divided by sine squared theta. So remember, to find the minimum value of this expression, we effectively have to find the minimum value of a half times this expression. So let's begin by considering sine squared theta. We know that the graph sine theta oscillates between -1 and 1, but when we square it, everything becomes positive, so that sine squared theta will exist between 0 and 1. We then take the reciprocal, and when we take the reciprocal, the inequality sign will reverse. So we're going to have 1 divided by sine squared theta being less than 1 divided by 0. This is undefined, and it's going to be greater than or equal to 1 divided by 1. So we have 1 divided by sine squared theta is less than infinity, that's undefined, but at the same time greater than or equal to 1. Then we're going to multiply everything by 2. Now multiplying by a positive number doesn't change the inequality sign, so we have got 2 divided by sine squared theta is going to be greater than or equal to 2, but at the same time less than infinity. So that's that expression there. This means that this expression will always be greater than or equal to 2. So the minimum value of this expression is going to be equal to 2. So now we've got that the minimum value of this expression is equal to the minimum of a half times 2 over sine squared theta, but we've established that the minimum value of this expression is 2. So simplifying this, we're going to get the minimum value of this entire expression being equal to 1. And this occurs when sine theta is equal to plus or minus 1. And this means that when theta is equal to plus or minus pi on 2, that's when we have the minimum value. So now that we've established that the minimum value of our original expression is 1, and this occurs when theta is equal to plus or minus pi on 2. So going back to our original definition where we define z to be equal to cos theta plus I sine theta, the minimum value of this expression occurs when theta is equal to plus or minus pi on 2. So we're going to substitute this value into here. So this means that when we sub theta is equal to pi on 2, we're going to get z is equal to cos pi on 2 plus I sine pi on 2. And when we sub theta is equal to negative pi on 2, we get the other value of z, which is cos negative pi on 2 plus I sine negative pi on 2. And simplifying this, we get z is equal to 0 plus I, or z is equal to 0 minus I. In other words, the values of z for which the minimum value for this expression to occur is when z is equal to I or negative I. Thanks everyone for watching the video. I hope you guys found that useful. For more videos on this topic or other topics, please do check out our channel. If you haven't already, don't forget to subscribe. We do release videos weekly, and we would love to see you all in the next one. Bye for now.